Cool. All right. So let's get started. Hello, everyone. Thanks for joining. We've got our first Australian host of a LogRocket tech meetup, and these are new. So please, that's me. I'm Luke. I'm the director of growth at LogRocket. And yeah, I'd love to hear your feedback on the topic, timing, sign up process, anything you want to complain about. Send your complaints to me or positives, and I can send those along. Yeah, really excited today. Luke Denton is here from Allegiant Consulting. Allegiant? Yeah, I pronounce it. Cool. And we're going to look at React hooks for infinite scroll. I think it's a really, really great kind of use of React hooks. This is like a really nice experience for end users. And yeah, so before he gets started, we do a couple more scheduled meetups, and my goal is to get like 10 more before the end of the year. So keep showing up, and I think we're digging into existing LogRocket content on the blog and just a new kind of way to interact with it and learn. So actually on Thursday we've got building a progressive web app with Svelte, which I'm really curious about. Like it's very something I'm not familiar with at all. And then actually same goes for GraphQL and your QL library. So a bit of a different focus there, but that's on November 17th. So yeah, and before I hand it over to Luke, this talk is brought to you by LogRocket. Hopefully you're pretty familiar with our blog or maybe with our product. I know Luke's a user. Yeah, we're a session replay solution in front-end performance monitoring to help you kind of fix issues faster, understand how users are interacting with your applications, and just build better kind of products. And I did want to quickly show, just based on the kind of topic tonight, when we're thinking about infinite scroll, like performance is key, and that's a core part of what Luke will be talking about. And here you can see just in LogRocket the kind of session playback. We've got someone shopping for a dog toy or something here. And with infinite scroll, it's a big impact on the browser. So what LogRocket can do, and I did want to highlight this, is actually go look at CPU usage and memory usage for every single person in your web app, in your website, in your mobile apps too. So as we're thinking about handling, like if you're infinitely loading 900 components, you could actually go use LogRocket to see like, oh, that's really kind of messing up the end user performance. So that's my spiel. I'm going to pass it off to Luke now. So thanks for listening to me.
Fantastic. Thanks, Luke. Yeah, as Luke mentioned, we do use LogRocket at our work, and I wanted to share a quick story of we had a React checkout go live, and we used LogRocket to watch the checkout. Obviously, the checkout's a quite important part of the website, so we want to make sure everything's working. And we had a bug come through where a user wasn't able to modify their cart. And looking back through the LogRocket sessions, we found that user, and we could see that their session, the view of the checkout would change from one split second to the next. And that was odd. We wasn't really sure what's going on. We weren't watching the whole website, so we couldn't see how they got there. But what we surmised is that they had the website open in two tabs. In one tab, they logged in. In the other tab, they weren't logged in. They were trying to make changes to their cart in the tab that they weren't logged in. And because LogRocket stitches together a user session, we were able to see both of those tabs, not obviously at the exact same time, but from one to the other as they changed. And yeah, we were able to figure out that there were some issues with cookies. So that was a fun one. I don't think we could have got to the bottom of that without a session replay tool at all. So LogRocket certainly saved us there. Cool. So I will.
Yeah, you should be able to share your screen.
Stop your screen. That's fine.
Yep. Cool.
Okay.
I can hear.
So, introduction. As Luke mentioned, I'm Luke Denton. I am a software engineer. I have a love for the web and all things websites. I'm also a maker in my spare time. I like woodworking, electronics, you name it, I like to build it. I have been able to culminate all of this into my Christmas light display at the end of the year, which is pretty exciting for me. and something I would not shut up about if I was asked about it. What do I do day to day? I work for Allegiant Consulting. We're in e-commerce. So a little bit about Allegiant. We're a growing team of 80 e-commerce experts across engineering, design, user experience, quality assurance, strategy, and solution architecture. We have been delivering industry-leading results for Australian and international clients for over 12 years, with the honour of being recognised for our work through multiple industry awards. Now, to start, I was keen to find out a bit of history of Infinite Load, specifically where it came from. I always assumed, incorrectly it seems, that Facebook might have invented it. Facebook may have just made it a bit more popular, but they certainly didn't invent it. It was actually invented by Asa Ruskin in 2006, working on his Humanized Reader project. So Humanized Reader was a news aggregator. Basically, you can think of it as like an RSS reader. And the whole idea of it was, don't force the user to ask for more content, just give it to them. He did a Google Tech talk on it in 2008, where he talked about a New York Times website. They would typically split up their articles across multiple pages, sometimes over 3 pages, for various reasons. Their analytics showed that as the users moved from the first page to the second page, there was a huge drop-off. And he found that as soon as users were given a choice to continue, they often didn't. So clicking. So the style of infinite load, as we know it today, that was used in aggregators is actually called the river of news, a river of news. I thought that was quite interesting. I'd never heard of that term before. So I wanted to find out a bit more about it. It doesn't seem to be used too much anymore, so I could only find old articles, but I did happen to find a definition, which is really good. That definition being, if it requires more interaction than simply scrolling, it is not a river of news. So how does that relate to today? Well, we're talking about infinite loading, infinite scroll, endless scroll. It's very similar approaches, and it's essentially the same pattern. So why do online retailers like infinite loading? Why do Facebook, Twitter, blogs, and news sites all like infinite loading? Well, for the very reason it was invented. It increases user engagement, and it ensures the user stays on a website. So this translates to real income for the site through ad revenue or online sales. So let's talk about implementing infinite loading. First, a quick explanation of the tech stack. So as mentioned earlier, we'll be using React. We'll be using some React isms, so hooks. However, this doesn't mean that these ideas and techniques we're talking about are exclusive to React. We're certainly going to use React to make it a bit more convenient for us today, but they could also be applied to all the other frameworks, including no framework, if you just happen to be running vanilla.js. So let's start with a basic infinite loading hook, one that manages state, products, getting more products, and that's about it. So we'll jump to some code first. A real quick overview of the code that we have opened here. These are a bunch of example components that we're going to be swapping through as we go through the talk. Basic header and footer, PDP. It doesn't have any information on it other than how to go back, and the product card that is going to render the product details. And then within main, I'll be swapping out the example PLP. We have all our hooks here. So these are the different hook examples that we'll work through, and a util function. I'll get to that in just a second. So our first basic hook we have here, it accepts some arguments, a get items property, which is a function that is to actually get the next item. So make a network request. The implementation of that can vary. It could be GraphQL, it could be REST, it could be a local file lookup. So for example, in our demonstration today, we are just going to be using a local file lookup just to save on me having to mess about with any network stuff. But we're sort of mocking a network request in that we're returning a promise and we're using a delay of 300 here. We're going to be playing with this value later on to see how certain things change with our infinite loading. So that's that. We set up our state, so items, empty array. We set up the page to load, so we're going to start from the first page. Track whether or not we've loaded the first page. If we don't actually manually or automatically load the first page, the user is going to have to click the load more button to even get started, which isn't an ideal experience. And has more, this is going to be a Boolean that will control whether the actual load more button is displayed or not. So here we are, the load items function that gets returned. We're just grabbing the data from our fake network. Set has more, so we update the visibility of the load more button depending on how many pages are available and what page we've just loaded. Update whatever the next page is. So if we've just loaded page 1, the next page to load is obviously going to be page 2. And then update our state, spreading out the new items with the old items into a new array. So this just appends everything afterwards. Down here, we've got a use effect that is using a ref to make sure that we're only going to do the initial page load once. So now within the component, we're destructuring our items, our Boolean and our function. That isn't important. Here, this is where we're rendering our items out. If we don't have any items, then we're just going to assume we're loading. Again, I said assume. This doesn't handle if there aren't actually any items. We would need to update some code for that. But we are dealing with a best case scenario right now where I can control everything. So I know that no items means we're loading. And then we will loop through and render all the items out. The key here, I just wanted to highlight this. This becomes very important later on when we talk about two-way data loading. And we need to make sure that it is unique to the product data that we're actually rendering within the product card. Down further, we've got our Boolean that's conditionally rendering our button, and then our action for the button, which is to load more items. Okay, so let's have a look at it. Start this again. Okay, we see page 1 loaded, 300 milliseconds, it's our delay. Scroll down, hit load next. There we go. That is almost, you could say that was a completed infinite loading hook. It does what it has advertised, I suppose. So as we talked about, hook API accepts a function and it returns the items, a Boolean and a function to trigger the get items function. However, there are some issues. What happens when a user goes to the product page and then comes back? So let's have a look. We've loaded 3 pages. We've got our V-neck hoodie here. I click on that, then I click back. Oh, we've only got 1 page of data, and we certainly don't have our V-neck hoodie. That's less than ideal. So the first page of products is displayed. The loaded products are forgotten. So we loaded 3 pages, but we're only displaying 1 page when we go back. Can we at the very least load the right page? And yes, we can. We can use routing. In our case, we're going to use routed DOM because we're in the React ecosystem. If we're within Vue, we could use Vue Router. Within Svelte, we could use something called Svelte Navigator. If we're not using any framework, we can use window.location to roll our own. So, basic infinite loading with routing. Let's have a quick look at that. So I'll swap to my next example. I'll just show, nothing has actually changed in this PLP component. This is exactly the same. So we'll close that one down. The changes here, we have imported use history. We are then initializing our use history hook and grabbing our history object. Our page to load, that was previously initialized to 1, but now we're actually grabbing the page query parameter from window.location.search. And if nothing is set, then we default to 1. The reason we are using this directly is because we don't want to have to wait for propagation of data through hooks and things like that. This will be synchronous. We'll get the data immediately, and then we can make sure that our first network request is for the right page and not not page number 1, as we'll, in case we're waiting for that. Further down, load items has been changed to use history.replace. Now we're using replace because we don't want to just bloat up our browser history. And so if you use pressing the back button, we don't want it to just be loading the previous products pages. We want it to actually go back. And then the rest of it is the same. So we can see that in action. We can see page 1 has appeared. So I refresh that. Scroll down, load next. Okay, we just downloaded page 2 and it's replicated up here. Load next again. V-neck hoodie. Let's click on that one and go back. Page 3. There's our V-neck hoodie. Beautiful. So we've at least remembered the right page. So we've gone back to the right page. But we're on page 3. We know that, because page 2 and 1, how does the user get back to those? That's a bit tricky. So, quick recap. We've used history.replace, direct access to window.location.search. So we are now showing the selected products page. Lovely. But we still can't see our earlier pages, the data that we've already loaded. So what can we do to do that? How about persisting that data? So we're going to use some stored history. Back to the code. Option C. Again, let me just confirm. Nothing has changed within our PLP code. That's exactly the same. Sorry, I should have said earlier, PLP stands for product listing page. I may also refer to it as a category page. So we'll close that. But what we have changed is within this hook, and specifically within the whole app, actually, we've introduced a context provider. So it's been there the whole time. We haven't actually used it up until now. So this app context provider looks like this. We have a category history, which is a ref. We're using a ref because we don't want to have any unnecessary re-renders as we're changing this value. We have a function, add to category history, and get category history. So adding, we add an array of products and we use category to key that value. So we're not overriding another category's products. That gets set into the ref. And when we are requesting the data, we are saying, does this data exist? If not, we return an empty array. If it does, grab it, spread it out into a new variable, and then delete it. This could very well be considered over-optimization or premature optimization. We may not need to do it, but it's just to make sure that we're not having our history or our memory usage get too big, depending on how many values we're loading. So the rest of this is just normal context API stuff. I won't get into the details too much, but just to say, so context value will return these two functions. The React docs does a good job of covering context API. Now, back in our hook, we are importing use.context and we are destructuring our two functions. We are using get category history to grab any stored data. So remember, this will return an empty array as if there isn't any stored data, so as items was before. But if there are stored data, then it returns an array of items. Next, we have added a +1 to page to load. Now, the reason for that is when we go to the product page and then come back, we are going to display the products from page 1, 2, and 3. And the URL will display page 3. So the next page to load isn't page 3, it's actually page 4. So that's why we need to add the +1 there. And then again, this is all the same, moving down. Here we use effect whenever the items array changes. Let's persist that. So add to category history. And then further down, we say, when we do an initial page load, do we have items already? And if we do, let's not worry about loading items because we've already got the items. So let's have a look at how that works. So that, start again, go down to our third page, and click on V-neck hoodie, and then we go back. Look at that, V-neck hoodie actually got scrolled and we have 3 pages worth of products. Fantastic, we go to the next page. Let's click on this crew neck sweatshirt, go back. Oh, look at that. We're getting scroll restoration as well. So we got history, it now restores. We even get scroll restoration. As I mentioned before, we didn't have that. So why do we get it now? Well, that's because the page that we're going back to is the same height as when we left it. But what happens if a user refreshes the product page? So we go to our sweatshirt, we, for whatever reason, accidentally, purposefully refresh, it could happen, and we go back. Well, we're certainly not seeing our sweatshirt anymore, and we go to page 5 as well. That is because we've done that +1. So to avoid accidentally losing that data in memory, we could use session storage or local storage. And that would certainly help. And that would allow us to recall the data across a page load. But the issue with that is that we've now introduced caching and the headaches that come with caching. So what happens if the product becomes unavailable? A product becomes unavailable, or the prices change, or the images change, or the available configurations change. How are we going to invalidate the cache that's stored in session or local storage? We have server caching available. Services like Varnish and Fastly, they're fantastic at caching data. they allow us to programmatically delete and clear that cache and then warm it again, so that the user is always going to be downloading the most up-to-date data. So it's best not to do that in the browser, because it just adds unnecessary overhead that we have to manage in our front end, which get very complicated. So what are the alternatives? Infinite loading in two directions using a load previous button. Back to our code, we implement number 2. So our PLP has changed slightly. We are now accepting a few different functions and variables. Quickly go into the hook, go through this first. We're back to just initializing with an empty array. No longer adding +1, that's back to a normal. All of this stays the same. We get down to here. We have 2 new state variables. So we has more it was before, it's now been renamed to has next, and we also have has previous. Now the way they're used, has next is exactly the same as has more before. We compare the total pages with the page loaded. If the page loaded is less than total pages, obviously we still have more to load. And then has previous just compares the loaded page to 1. We know that we're not going to have a 0 page or any negative pages. So as soon as we've loaded page 1, that's it. There's no more previous pages to load. Next is the way we update our items array. Because we are loading data that should be displayed before the current items, we have to conditionally either spread them out before the previous items or after the previous items. And this is where we use the item combine method that is passed in through load next and or load previous. So again, load next is making use of the page to load, adding 1, then updating the URL to display the page we're about to load, and then loading those items and saying, okay, append this data. Load previous does the exact same thing, except it says prepend. And then down here when we are initializing, we're always appending. So quickly through the component code, here's our has previous, or here's our new load previous button with has previous conditionally rendering it. Load previous is the action. Similarly down here, this has just been refactored. The rendering of the items has not changed. Oh, we can see load previous has appeared. Okay, refresh, start again, load next. Load next, we get down to our bin equity, click, and then go back. On page 3, we can see our bin equity, and we have a load previous button. So fantastic, we can now get to page 2 or page 1. Great. And we can also get to page, so we have some warnings here, duplicate key. And we can see what has happened here is we've downloaded the same data. So we can see Olivia Quarter Zip Light Jacket is here, but it's also here. So we just downloaded the same page twice. That doesn't seem to be right. Yes, there's a bug. We need to track the highest and lowest loaded pages. So let's go to the next example, 3. So this hook has now been updated to include 2 new refs, lowest page loaded, highest page loaded, and these essentially replace the use of page to load. So page to load has now been refactored to initial page. It's only going to be used to initialize the values, and then it's not used again. We can see load next is now using the highest page loaded current value to determine what its next page is, and load previous is using the lowest page loaded to determine what its next page is. And within the, I don't think there's any changes there to talk about. We'll go over to here, quickly demonstrate this as well. Scroll down, load next, scroll down. Load next, let's click on bin equity, go back. Okay, load previous. So now what we don't want to see are any warnings. So if I hit load next, there we go. All new data, and we can keep moving forward. So those refs would help us to determine exactly what the next page actually is. So again, routing only provides a start value. We use refs to track the highest and lowest loaded page. And refs are used for the load previous and load next logic as well. So let's get into automatically loading more items. This is probably the pattern that most people are familiar with. So that's number 4. So how are we going to do that? Well, we're going to use the intersection observer. I'll jump back to my notes, the intersection observer. However, I don't want to mess about with using the API and making sure I have cleanup functions and such. So I'm going to use React call in view. It just makes it a lot easier to use the intersection observer within React. And then this goes back to what Arzo had said initially with his humanized reader. Don't force the user to ask for more content, just give it to them. So we can have a quick look at the initialization. It's simple. This is all it is. It's really straightforward. It returns observe, which is a ref, and then what happens when that ref is within the viewport? Well, we want to load the next page. But don't worry about root margin, I'll get to that in just a second. The PLP grabs that ref and then adds it to the button. Really simple. Let's start this from the start. And as we scroll, we get our automatic. So notice I'm not clicking that button, it's just happening automatically. That's really good. Awesome. Now, one thing we notice is that load previous came up straight away. And if I start from the start, I appear to have loaded page 1 and page 2, but I haven't done any scrolling. So why is that happening? The reason, the load more button starts within the viewport. So if we refresh, there you go. So we can see the load more button before all the products loaded. The intersection observer also saw that and said, oh, okay, we're within the viewport. Let's load the next page. How do we get around that? We can use a UI technique called a skeleton UI, or we can add a container minimum height. Now, essentially, we just need to make sure we push that load more button outside of the viewport so that on initial render, it's not actually there. We do have to be mindful with a container minimum height. If a product or a category page doesn't have many products, we could be left with a bunch of white space above the footer. Now, I do have an example. Let me quickly jump to that. That's 4B. So the hook hasn't changed. We're still using the same hook. But what we've done now in the PLP example is we've implemented this placeholder products. So this just loops through. It does a pretty not great way of creating an array. So don't focus too much on that. It's more just the idea that we can set up a bunch of skeleton products. And we can see how that works. Within here, look at that. That is our skeleton, that purple, those purple elements. And not only have we defeated layout jank, because you can see nothing is moving, it's just being replaced, which is fantastic. We're also only downloading the first page. So this prevents the load more button from being seen on page load. Now, I mentioned that root margin. This is just a quick aside for intersection observer. If we give this a positive value, this essentially increases our viewport. So instead of our viewport ending here, it actually ends 500 pixels down there. Now, why would we want that? Well, that makes sure we never see the load more button. You can see as I get almost to the bottom, we're loading the next page. So why have I chosen 500? That's the height of this. So essentially, as we've got one row left, the next page will automatically load. Oops. So we've got quite a good looking hook now. We're able to load more items automatically. We're giving users content without them having to ask. Users are focused only on the products and not on trying to load more products. We could easily call this done. We could say, yeah, we're good here. But we could also go a bit further and try and make it the interaction and the experience feel near instantaneous. So let's talk about some perceived performance. So what is perceived performance? Well, as the name implies, it's the perception that something is working really fast and being incredibly responsive when that might not actually be the case. How does it apply to our infinite loading hook? As we've seen in the app so far, as I'm scrolling down, we get to a point where the next page of products is loading, and I'm waiting for the network request, or a fake network request, to resolve before the app can render the new products. For users that have a fast internet connection, we're probably not going to see an issue with this. However, if users don't have access to 4G or 4G/5G, or they're in an area with spotty internet connection, they'll be sitting and waiting for potentially a while, which could get quite frustrating. We could use a technique called preloading to have the next set of products ready to go as soon as the load more button is triggered. So again, the quote that Arza used earlier on was, don't force the user to ask for more content, just give it to them. I've taken this opportunity to add a little bit more to it, and don't make them wait for it. So a little bit of a sequence diagram to try and explain it. I'll quickly go over this, but we will look at it in practice and in the code. So the user comes in, accesses the category page. The category page will request the first page of products and return that to the user and render it. But whilst the user is scrolling through there, the app has gone and requested page 2 and then stored that page 2. When the user clicks on load more, we immediately return page 2. So the user is seeing them, and then we go off and request page 3 and then store that in memory, so on and so forth. So that was a little bit quick of a explanation. How about we actually look at it in program, in action? So we go to number 5. So I'll reset all of this and we can watch it happening. So we can see, okay, again, we've loaded 2 pages of data, but the URL is saying I'm only on page 1. As I scroll down, I don't see any, I'm not waiting at all. So one of the names is bigger than the column, so that's why it's just shifted like that. But as I'm going down, there's no perceivable stopping. I'm just scrolling endlessly until I get to the end. So that's the perceived performance. To me, it felt like I was just scrolling one long page, but in reality, it was just loading at certain times. It might be, hopefully it's not, it might be a bit complicated to try and go over the code, but essentially we have a little debounce here is in flight. So if we're requesting the next page, we're not going to do it multiple times, and we track the next items in a ref. And we can see that when we are prepending, we're not actually caching that data, we're not storing it, so we just request that from the network. But if we are appending, we grab those items from next items, set that to the items array as we did before, as if we had requested that from the network, clear out the next items, and then if we haven't loaded all the pages, we go ahead and grab that next page, which is page +1, and then store that into next items. So trigger next, this is again for the little debounce. And the rest of this is exactly the same. Within the PLP, nothing has changed. So I'm aware this is quite a bit of code. I'll certainly chat with Luke and see how we can get this available to everyone to actually have a look at and play around with. So yes, we'll go back to, that's what I want to do. Let's play around with this. So I mentioned this earlier. This is our delay. Let's make this 1 second. So what we're going to see is we'll start from the start. The first page, that's a perceivable delay in the product actually being loaded. But as I'm scrolling, I don't ever see that again. So we've effectively compensated for that delay by preloading the next set of data. Now I have another. Okay. Now, if we're downloading the data, why not just display it? Is it wasted bandwidth? So if we're downloading one to display it, well, we don't want to overwhelm the user. We still want them to be in control of when it's displayed. If they don't scroll down far enough, if they select a product that's up higher, then there's no need to download the rest of the pages, and there's no need to render them. There's no need to put that strain onto the browser. As Luke mentioned earlier, if we have a lot of products within a browser, the browser is going to get sluggish. So we'll only render it when the user needs it. Again, is it wasted bandwidth? Well, maybe. Maybe we download that next page and the user never sees it. That could be considered wasted. For the most part, it's just going to be text though. So it's not going to be too big of a download hit. We're not actually downloading the images until they're rendered to the browser. So in saying that, we can actually be conscious of our users. So there's a network information API. It is experimental, but it gives us the ability to check the effective type of internet connection, be it 2G, slow 2G, 3G, etc. And we can also check whether the user has saved data enabled. So this is a setting that users can typically put on their phones, but you can lock it on desktops to say, okay, I want as little data as possible. Applications like Gmail would probably then revert back to their really basic HTML view. I can actually demonstrate that, I think. Let me quickly check, sorry. 5B. So within 5B here, we now have this check here, client can preload. So we are checking navigator.connection.effective type. Is their connection slow 2G or 2G, or have they got saved data enabled? So just simply with that, and then using this Boolean in various places, we can actually, I can demonstrate it by changing the network to be slow 3G. So this is, it just reloaded without having the slow network. We can see we've loaded 2 pages, but if I do it now, we only loaded 1 page. So the browser has detected I'm on a slow internet connection. It's probably not going to be, I'm on a very slow internet connection. The user probably won't be able to download data within the amount of time. Similarly, I haven't figured out how to mock the saved data yet, unfortunately, but it would have the same effect. Next. I'm sorry. Interesting. Arza Raskin has recently apologized. So he came out and said, sorry for inventing this. The infinite load pattern has been linked to social media and smartphone addiction because of the way it sort of psychologically tricks users into staying on the website. So what if we want to actually consider our users' well-being? Well, we've talked about manual infinite loading with our basic hook. We've talked about automatic infinite loading, aka infinite loading. I like to say that. What about partial infinite loading? And then creating a hook API to specify a loading type. So let's look at what that could look like. So up to 6. So now in our PLP, we are passing in get items, yep, but we now also have options. We have a loading type, we have a preload, and we do actually also have a partial infinite load limit, which is an integer. So if I say, okay, loading type is partial, preload is safe, so that's going to factor in the user's internet connection and their device settings. And we want to partially infinitely load 3 pages. After that, we're going to revert back to manual. So we can have a look at this again. Refresh. Oops, let me take off the slow network. And also revert that delay because that's everywhere. Okay, back to quick. Scroll down, automatically loaded, and then we stop. Oops, that's a spoiler. Let's not look at that just yet. But now we can click load next. So now we've fallen back to the manual infinite loading pattern. And then this was implemented fairly straightforwardly. So we just accept these options, determine whether preload's off. So that will work similar to whether the client can preload. It's just another bailout condition. The partial infinite load limit, -1 means there is no limit. So that's the default value. And then we are using our other loading type within our, or we're setting in state here. And I think that's it. I think I've actually spoiled the next little bit, but that's okay. I'll cover that in just a second. Yeah, that's a lot of hook. We've covered a lot in putting together this hook. But is there even more we could do? Could we actually give control to the user? What if we, in our storefront, choose to use manual or partial, but the user actually prefers automatic, and they would much rather view the website that way? Well, as I somewhat spoiled just before, let me change this back to manual. I'll do this because it has no bearing anymore. Save that. What we can do is let the user tell us, I want automatic, and then hit load next. And then it's just all automatic from there. Now that's something that I've been playing around with. It certainly hasn't been implemented anywhere in our sites yet. It's something I want to discuss with some UX people first, because now that we've turned it on, we have to also give the user the ability to turn it off. But without preloading, we're never going to see that load more button again. So there's some UI UX to that, but it's just the consideration to give the user a bit of power to actually control what's going on. Okay, just quickly, I like pagination numbers. What if you like the numbers displayed along the bottom? And that's what your website has currently. You don't want to have to mess about with implementing the load more button and changing the way that your state works. Well, we could do that also. We go to number 7. So a quick look at this number 7 PLP. We've got buttons here that are rendered out, the total number of buttons. Refresh this, let's start from page 1, that might be better. So see all of our buttons, 1, 2, 3, 4, 5, 6, 7, 8, 10. We have loaded page 1 and we preloaded page 2. So if I hit page 2, we immediately go to it. Now I haven't added a scroll to top, that probably would be best. But that's just that's outside of the scope of the use infinite load hook. And again, we've preloaded page 3. So it's instant to get to the next page. Now, obviously with page numbers, I could jump to page 8 and there is a delay because we can't really preload every single page. I mean, we could, maybe it might not be the best idea, but it's something that's possible. We assume that the user is probably going to go through logic in the sequence 1, 2, 3, 4, etc. So we can just preload the next page. Okay, what if you don't use React? You use Vue or Svelte or even vanilla or something else? Well, as I mentioned, these are loading techniques. Routing doesn't have to be handled by React Router. We can use window.location or the routing from the specific frameworks. We've used a lot of refs, which are essentially just regular variables. Using the hook to neatly wrap our functionality. But we can use that as a utility in any other framework. And we've used state in a few instances for our reactive variables. But again, other frameworks have reactive variables, or if we're using vanilla.js, then we just use the same technique that we're using to update our DOM already. So these techniques still apply across the board. Okay, boy, we've gone through a lot. Some references, here's some links in case people wanted to check it out. This is the tech talk from 2008. It's actually quite interesting. There's a real funky concept introduced there that certainly didn't stick, but it was still amusing to see, I suppose. The Humanized Reader blog. So these are a couple of blog posts by Arza Raskin. They're on the web archive because the Humanized project has since shut down. And then finally, the Arza Raskin apologizing. Unfortunately, that is behind a paywall, so some people might not be able to see it, but it is there. And that's everything. So I am done. I will stop sharing screen.
Awesome. That was great. Yeah, I was thinking like, yeah, social media, and then e-commerce, obviously, but then all the news sites now implement this really heavily. And it's usually quite frustrating. We won't put that on the blog. Yeah, did anyone have any questions for Luke? Looked like no. I have one question about how you implemented. Sorry.
I said, hopefully that means that I covered everything to answer all the questions prematurely. So,
when that was it a library? How you implemented interaction observer? What was that called again?
Intersection observer. Yeah. So React cool in view. It just makes it super simple to wrap.
Okay.
Yeah. To do it in React, you have to, with the intersection observer API, like the vanilla API, you have to worry about cleaning up functions and making sure that you're not opening it yourself up to memory leaks and things like that.
Yeah.
I just wanted something else to handle that for this demonstration. And even in normal apps, it works really well. So
that was my question. Yeah, you don't have to like manually unset it and like handle all that. Wow, that's really cool. And then yeah, the network information API, it's a really good use of this.
I forgot to say that it's available in all the desktop browsers except Firefox and I assume Safari, but it's available on all mobile devices. So Firefox mobile as well, except for Safari. So I think the biggest use is on mobile devices. So that's why it has been implemented there. So it probably won't be experimental for long, but it is still a caveat that it is experimental for now.
Yeah. Awesome. Yeah. The only question was, will there be a recording? Yes, there will. I'll have that up in like an hour, and I'll send it out to everyone. This was really great.
Cool.
So, yeah. Thanks everyone for coming. And,
thank you.
Yeah. Infinite scroll. Great. See you later.